Okay, welcome to Scalable Ad Hoc Geocasting. Today I'm going to describe a little bit about what we did in our paper. The title is Scalable Geocast for Vehicular Networks. It's done by Rajesh, myself, Ritwik, Bob Hall, Josh Hausen, and Vanith Agarwal. We're from AT&T Labs Research. So I'm going to just basically quickly describe what it is. We talk about vehicle-to-vehicle and vehicle-to-infrastructure communications, and geocasting is an important class that facilitates V2V and V2I communications infrastructure. Geocast protocol should be able to function without any fixed infrastructure, and we want to be able to send messages from a certain car to another car in an ad hoc fashion. And we have done real experiments. We've also done simulations, extensive amount of simulations. So the opportunity is to evaluate how well a geocast protocol performs under realistic vehicular conditions. So our contributions are that we've implemented a scalable ad hoc geocast protocol, which was originally invented by Bob Hall, and we've implemented that protocol in the context of vehicular communications. We've actually done some real-world experiments, and our field results show that we're getting more than 90% of success sending messages from one car to another car. And finally, we've done lots of simulations on different kinds of scenarios, single lane, multi-lane, obstructed highways, and things like that, so that we can actually understand how well geocast performs. So what is a geocast? A geocast is basically trying to send a message to a geographic location. And this is different than sending to a particular IP address or a host name. The number of recipients is usually unknown. So all you need to know is that we're going to send it outright to a certain place in a certain location. Here you can see that we have a trail car and we have two lead cars, and the aim is to send messages from the trail car to within this green circle in the lead car. And there are some fixed infrastructure here like iPhones, laptops, and basically the messages are hopped from point to point at this point, and the lead car is moving and the trail car is moving along this particular directions. And we wanted to show how basically the success rate is. The success rate is over 98%.
Start. Hi, I'm Rajesh Panta. I will explain some of the simulation results. Because we could not do the real-world experiment with large number of vehicles, so we used some simulation for large-scale experiments. We use Sumo to generate the mobility trace of the vehicles. We used real-world experiment traces from real-world experiment to find both mobility trace and traffic trace. We also used real-world traffic data from collected from AeroCab in San Francisco City. And here are the different parameters that we use for our simulation experiments. We varied the speed of the vehicles, and we evaluated how the number of number of vehicles that get the geocast message in the destination region change. And we find that the number of vehicles that get the geocast message is almost 100%. It's close to 100. The hit percentage is very high. It's almost 100%. Here, hit percentage is we calculate only based on feasible targets. And finally, this figure shows that the number of transmissions per geocast it decreases with the increase in speed. And this is because with the increase in speed, the vehicle density decreases. In conclusion, what we did in this paper was we applied geocast protocol developed by Bob Hall and his team in the vehicular context, and we evaluated the protocol in with real-world experiments and also with simulation. And if you have any questions, you can contact us, and we'll be happy to respond to you.